All right, let's take a look at this test review. So this is our test over, I think, our 10 series tests that we're looking at. And remember, the test that we're taking is 15 multiple choice. That's 3 calculator problems and 12 non-calc. So calculator, it's things like finding the sum of a telescoping series, finding how many terms it takes to get a certain error, things like that. Okay, determine whether the series converges or diverges. State the test used. So remember, sometimes the more than one test can apply. So I could do integral test here, but I avoid that at all costs. Usually, if I could do integral test, I can maybe also compare this to something. So I'm going to compare 5, excuse me, 5 over, actually, I want to put my work down here. Sorry. I want to compare 5 over n plus 1 to just 5 over n. The first fraction is smaller. And then we know that the series of 5 over n is a divergent harmonic. Now remember, you're about to take a multiple choice test, so I am still writing everything out, but you don't necessarily have to do it. I mean, it's good to do it, but you don't need to waste time doing every little detail if you don't need to. And then I need LCT on this because the top function is diverging, which has no effect on the one that's growing faster. So I do a limit as n approaches infinity of my unknown divided by my known. As long as this comes out to a number, then the two series act the same. So this comes out to 5n over 5n, so that's 1. And yeah, so since I got a number between 0 and infinity, these two series act the same. So that means that this series also diverges by LCT. If you did integral test, which is allowed because the terms are positive, decreasing, and going to 0, you should get the same conclusion. All right, for the next one, again, I could do, hold on, sorry, let me add this in, or integral test. I could do integral test on this one, but again, I don't really want to. If I'm looking at multiple choice, they're not going to have both tests that would work. So, or if they do, the conclusions would be different. So if I were to do integral test on this, u would be ln x, du dx would be 1 over x, so it would work. I'm just going to use a comparison test again. So ln over n, I'm just going to compare that to 1 over n. I don't want to compare it to n over n because then that's just like 1. But this is a harmonic series. The top function is greater than, or the first one is greater than because ln of n will be greater than 1 if we start at 2 and go on from there. Actually, well, I guess ln of 2 is not greater than 1, but in the end, ln of increasingly large n values will be greater than 1. All right, because I know ln of e is 1, so that's why I corrected myself. All right, so the sum from 2 to infinity of 1 over n is, again, something divergent. And this one, DCT, works because if the faster function is not fast enough and it diverges, then the slower one is also going to diverge. So diverges by LCT. Nope, not LCT. DCT. I will say this in class today, but on the multiple choice questions, they don't usually say direct comparison test. They just say comparison test instead of direct. So FYI on that. They will say limit comparison test or just comparison test. All right, for number 3, we have 1 over natural log of 2 to the n. So remember, natural log of 2 is a number, and I actually just talked about this. The question is, how does it compare to 1? Because we know that, 1/2 is less than 1, but what about 1 over ln 2? So ln of e is equal to 1. ln of 2, which e is 2.7 dot 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 dot. So ln of 2 is less than 1. So when you do 1 over a number that's less than 1, you're going to get something that's bigger than 1. All right. So that means that 1 over ln 2, that r, is greater than 1. So this diverges. And it could either be, gosh, I can't write today. It could either be by geoseries test, or it could be nth term. All right, let's take a look at the next one. We have n times sine of 1 over n. Now, what about nth term on this one? If the sine wasn't there, this would just be going to infinity. But the sine is there, so what happens to this? N times sine of 1 over n. Now, in this, I get infinity times 0, and remember, that's one of our indeterminate forms. So we don't know that this is infinity or 0. If I want to keep going, because I don't really have anything else to do with this, I don't want to do integration. I can't compare it to anything. So I'm going to keep going with this limit. I'm not finished with it yet. This is going to be like a little L'Hopital's method, where we need to rewrite this as something rational first. So let's make it sine of 1 over n over 1 over n. Instead of times n, divided by 1 over n. And then let's take the derivative of the top and the bottom. So we're using L'Hopital's rule. So the derivative of sine is cosine of 1 over n. And then I have to do the chain rule. The derivative of 1 over n is minus 1 over n squared. And down here, the derivative again of 1 over n is minus 1 over n squared. So those are going to cancel. Try direct substitution again. This comes out to cosine of 0, which is equal to 1. So all I've done so far is take the limit as n approaches infinity. I did a couple rounds of L'Hopital's. I got 1. So the terms are approaching 1, which is not 0. So this diverges by the nth term test. All right. I'm sorry there's like no room to write in here. I don't really know why I haven't spread this worksheet out, but okay, take a look at this one. If the plus 1 weren't here, I could simplify this thing. So that's your hint that this could be a comparison test. So let's compare the square root of n over n squared plus 1 to square root of n over n squared. So the plus 1 makes this a smaller fraction. Subtracting these exponents to simplify it for the series I want to look at. 1/2 minus 2 is negative 1/2. So I'm going to put n to the 3/2 down here. All right, and then I do know that this p series, 1 over n to the 3/2, I know that that converges. It's a convergent p series. And so if the one on top is converging, then the one on the bottom, which is decreasing even faster, also converges. So this converges by direct comparison test. Or again, they will just say comparison test. Right? Looking at number 6. 3 to the n minus 1 plus 1 over 3 to the n. Some of these are looking familiar. We might have some repeats from some homeworks and things. All right, so let's do a comparison test again, because this is like, or you could do ratio test. But I'm just going to compare because I can cut off a plus 1. If this were like plus n, I think I would do maybe a ratio test. So I want to compare, I'm not going to rewrite anything. I just want to compare this. Compare this to what? So let's cut off the plus 1. Let's make it 3 to the n minus 1 over 3 to the n. So if there's a plus 1 in the numerator, that first fraction is bigger than the other one. And then let's simplify this. So 3 to the n minus 1 over 3 to the n is just, you subtract these exponents, it's just 3 to the negative 1. So this is just 1/3. So that's pretty weird. What do we know about a series that's really just like 1/3? you would just keep adding 1/3. So this diverges by nth term test. And that's kind of a strange thing. So what if I'm like, okay, something went wrong. This isn't one of my series. Let's look at this a different way. What if we start with Hart method here? So let me do this in green. This might be what I had on my answer key. 3 to the n minus 1 over 3 to the n is, again, like I said, 1/3. And then you're adding to that this other series. I guess this kind of gets me to the same place. 1 over 3 to the n. So even though the second series converges, the first one diverges. So you get this like infinity plus whatever this one adds up to. I guess it'd be 1/3 over 1 minus 1/3. But that's infinity overall. Okay, so what's happening to this one? I would say diverges. What's the reasoning here? I think just nth term test. Because I didn't really compare it to a known series in the end. As I was making this comparison, I kind of just got a constant rather than like a p series or a geometric or something. So I would be looking for diverges by nth term test. And actually, oh my gosh, what did I just do? So actually, there we go. I'm just going to erase this because I have it written right here. All right, so kind of a weird one. Again, take a look at the multiple choices to help inform which way you should be going. If they don't have any comparison tests, then and they do have nth term tests, then try that. All right, what about this one? We're comparing 10 to the n to n to the 10th. And my gut reaction here is that this is not going to pass the nth term test. It seems very top heavy. So let's just kind of verify that. If you're not sure, you could do ratio test here. And I know it's alternating, but the question is like, what about 10 to the n over n to the 10th? Now, I could do a bunch of derivatives, but if it's n to the 10th, technically to prove this is going to 0 or going to infinity, you would have to do, 9 or 10 rounds of derivatives. But this polynomial, after enough derivatives, it is going to go down to a constant, whereas 10 to the n is just going to keep compounding. You're going to get the derivative of 10 to the n is 10 to the n times ln 10, and you're just going to keep getting that compounding on itself. So this is definitely infinity. I don't need to do all the derivatives to show it. So this diverges by the nth term test. And yes, it was alternating, but remember the next thing you check is, are the terms going to 0? And they're not. All right, let's take a look at this one. Again, nth term test, or I guess this could be root test. Let's see. Yeah, root test, not nth term test, because it's to the n power. So let's do root test here, where we take the limit as n approaches infinity of n over 2n minus 1. So I get 1/2 for that. And remember, the root test says this thing is trying to be geometric. It's something to the n. And yeah, the terms are going to 1/2. So as long as I get a fraction that's less than 1, then this converges by the root test. You could probably also do ratio test on that, but it would take a lot more work to get there. All right, let's look at this one. I have n squared minus 1 over 2 to the n. It's kind of a weird combination. I don't want to do a comparison test because we don't have a known series that has a n squared over 2 to the n. So instead, I'm just going to, when it's kind of complicated like that, I just sort of default to ratio test, see what happens. So ratio test is where you plug in n plus 1. N plus 1 squared minus 1 over 2 to the n plus 1. Divide that by the nth term, so multiply it by the by the reciprocal of the nth term. All right, so what would you have? So the 2 to the n would cancel with the 2 to the n plus 1, and you'd have 2 to the first. Nothing cancels because the polynomials are not exactly the same up here. But you're going to have 1 n squared on top and 2 n squared on the bottom. So that's 1/2, which again is less than 1. So these terms will be decreasing in the end, and this converges by the ratio test. Next one is n squared over e to the n. So again, I don't really want to do comparison test. I know about 1 over e to the n, but you don't want to compare like a quadratic to just a 1. I only did that with natural log because natural log is pretty slow growing, so you can compare it to a 1 and it's okay. Maybe you could do a comparison test. Again, you would check the options, multiple choice, but when in doubt, you can try out the ratio test. Notice I'm kind of doing that when I have these mixtures of like polynomials and exponentials because you're trying to see is it ending up like a geometric in the end. All right, so plug in n plus 1. Divide that or multiply by the reciprocal of the nth term. And kind of the same thing is happening. So I'm getting n squared on top and en squared on the bottom. So this is 1 over e, which is less than 1. So this one also converges by ratio test. All right, next section. Determine whether the series converges absolutely, converges conditionally, or diverges. So that means that, take a look at these. They're all alternating. Even this one, because cosine of pi is -1, cosine of 2 pi is 1. Cosine of 3 pi is -1, cosine of 4 pi is 1. So all of these are alternating. So first we check that they converge. All right, so first apply AST. So yes, the terms are alternating. And then I take the limit as n approaches infinity. Let's look at this as 1/10 to the n, so it's more obvious instead of 0.1. Those terms are decreasing to 0. I'm not going to bother with the decreasing thing, so just, okay. I'm just going to say decreasing. Yep. So yes, this converges by AST. So if I'm running through multiple choice, I throw out the diverges option. And then the second thing that you check to get conditionally or absolutely is the positive version of this. So take out the -1 aspect of it, but keep everything else the same. So instead of 0.1 to the n, I'm going to make it 1/10 to the n. This is a convergent geo series. So I know that both versions of this, alternating and positive, are converging. So this series converges absolutely. All right, same idea for the second one. First, check to see if it converges. So yes, this is alternating. What about this limit? The limit as n approaches infinity of, this one's a little more complicated, isn't it? N squared over 2/3 to the n. So this is another infinity times 0 scenario. So that's indeterminate. So we need to work on this a little bit more. What if we try, so instead of alternating series test, because it's inconclusive right now, what if we try a ratio test? Because what were we just saying? Anytime I have something sort of exponential and polynomial, I try the ratio test if I'm stuck. So let's try that. The limit as n approaches infinity of absolute value, so ignore the -1 part, n plus 1 squared times 2/3 to the n plus 1 over the nth term, which is n squared times 2/3 to the n. So I'm left with 2/3 up here. And then it's a tie. 2/3 times n squared over n squared. That's 2/3, which is less than 1. So this does converge. It's just not by AST. It's by ratio test. You can still answer this question, conditional or absolute. Although I kind of just showed it, didn't I? So the series from 1 to infinity, if it were just n squared times 2/3 to the n, that's what I just verified. It converges by the ratio test. So this converges absolutely. I think in our notes for ratio test, it says if you get a fraction less than 1, this converges absolutely as in parentheses. I guess that's because you're proving that the positive version of this converges. So does the alternating. All right, number 13. We have alternating. The limit as n approaches infinity of n factorial over 2 to the n. Now that we know is infinity. So this series diverges by nth term test. And if it diverges, there's no absolute or conditional about it because it's not converging. Number 14, alternating. Yes. Limit as n approaches infinity of 1 over 1 plus radical n goes to 0 because it's bottom heavy. Yes. And those terms are decreasing. Okay. So this does converge by alternating series test. And then we check the positive version of this. Excuse me. So the sum from 1 to infinity of 1 over 1 plus radical n. This needs a comparison test. So we are comparing, I don't want to get into the workspace down here. So we're comparing 1 over 1 plus radical n to 1 over radical n. First fraction smaller. We know the series from 1 to infinity of 1 over radical n is a divergent p series because p is 1/2, which is less than or equal to 1. I need to do limit comparison test because if the top series is diverging, that doesn't tell me anything about the one that's decreasing faster. So that is the limit of your unknown. Limit of your unknown, there we go, over your known. No, I have that up there. That's 1. As long as you get a number between 0 and infinity, then these two things act together. So I know that this series diverges by LCT. So that means that my final answer for this one is that the series converges, the alternating series converges, but it's conditionally. It will only converge if it has the alternating piece to it. All right, I already explained how cosine is alternating in this one because multiples of pi bounce between -1 and +1. So it is alternating. The limit as n approaches infinity of cosine of n pi over n, it is going to 0 because cosine stays between -1 and 1, but the bottom continues to increase to infinity, so that's 0. So the terms are decreasing. So this converges by AST. Second thing is to look at the positive version of this. So what is the positive version? Well, if the max that, well, I guess you would just put like an absolute value around this. Let's just do that. I might not have done that in my answer key. But let me just write this out. So, okay, here's technically the positive version of that. And then, or you could just make it like cosine of, well, no, yeah, just make it positive like that. So you would do a comparison test. The absolute value of cosine of n pi over n, it's always less than or equal to 1 over n because the maximum this can be is 1, the lowest is 0, and anything in between, I guess any decimal in between would be smaller than 1. We know that the harmonic series diverges. And I would need to do LCT again because the top is diverging. That's having no effect on the bottom. So the limit as n approaches infinity of the unknown, excuse me, over the known. The n's cancel. You get cosine of n pi, whatever. So this is going to be like bouncing back and forth between, oh no, wait, this is absolute value, sorry. So not bouncing back and forth. This is going to come out to +1. And I got a number that was between 0 and infinity, so that means that these act together. So that means that this series diverges by LCT. So back to the original. I'm really running out of room here. Sorry. So the question was conditional or absolute. So again, this alternating series converges conditionally. All right, what about the back of this worksheet? So find the values of x for which this series converges. We do have something like this. We had it on our quiz, and we do have this again on our non-calc part of our test. So all you have to do with this is say, this looks geometric to me. And a geometric series will converge as long as this fraction stays between -1 and 1. So that's what you do every time. Set the parentheses between -1 and 1 and just solve for x. That's it. Identify the most appropriate test to be used to determine whether this series converges or diverges. So they're either, root test is definitely out because we have a cosine n there. Ratio test, maybe, but putting in a cosine n plus 1 doesn't really help us. We usually use ratio test when there are factorials or when we have like a combo of polynomial and exponential. So yeah, I would compare. I think I've been comparing this. And the question is just, would DCT work or LCT? So cosine of n is always less than or equal to 1. It's between -1 and 1, so that's true. And we know that this series, 1/2 to the n, converges. So direct comparison test would work in this scenario. Determine the convergence or divergence of this series using any test. So this is not bottom heavy, so it should be diverging by nth term test. So diverges by nth term test. I see both A and B. Would that be possible? Both A and B? Let's see. I don't know, because ratio test is only... Let me double check my ratio test rules here. Ratio test, term with non-zero terms. Yeah, I guess it doesn't say anything about that. I don't know. Let's run the ratio test. I originally have had just diverges by nth term test, but where's this thing? There we go. I don't know. Let's do a quick ratio test. Limit as n approaches infinity of 10n plus 1 over n plus 8 times n plus 7 over 10n. Oh no, see, ratio test is going to be inconclusive because you get 1. So inconclusive. Okay, good to know. So you can see, like, you might need to double check some things as you're doing this, just to kind of verify. So it's definitely this. All right. Use the root test to determine the convergence or divergence of this series. So it's all been nicely packed up for us here. It's all to the n. So that just means that you're taking the limit as n approaches infinity of just the 6n squared plus 1 over 10n squared minus 1. And you get 6 over 10, which is less than 1. So this converges by root test. Use the ratio test to determine the convergence or divergence of this series. So ratio test says go ahead and ignore the alternating piece because we're putting this in absolute value. This would be 4/5 to the n plus 1 over n squared. Over n plus 1 squared. Over n squared, or times n squared over 4/5 to the n. So that's going to cancel with that and leave you with just a 4/5. 4/5 n squared over n squared is 4/5. So that's less than 1, so converges by the ratio test. Determine the number of terms required to approximate the sum of this convergent series with an error of less than this. So they're telling you what the actual sum is. This is irrelevant. You would use a calculator for this one. So set it up here. We want to find the error between the actual sum and our partial sum. That's equal to the remainder of the partial sum, which is less than or equal to the n plus 1th term. And we want to keep that less than 0.001. So set this up. You're supposed to plug n plus 1 into this expression. So 1 over 2 to the n plus 1 times n plus 1 factorial. Keep that less than 1 over 1,000. You're allowed to use a calculator on the test that we have. So you can either plug this into your y equals or you can switch it around. So I'll show you both ways. So pop this into your calculator. Let's see. Go into y equals. And let me do the second way first. So 2 to the x plus 1 times x plus 1. Factorial is either math, probability, or it can also be found somewhere up here. Alpha, I don't know what it is. Alpha window. Yeah, it's down there. Oops. There we go. So I have that typed in. And then I'm looking for where is this greater than 1,000. Now, I don't know where my window is going to start. I've got it at 30. I'm going to go back to 0. That was second window, second graph. So it doesn't take long for this to exceed 1,000. It looks like when n equals 4, that's the first time I get bigger than 1,000. So I'm getting n equals 4 for that. And then it says find that fourth partial sum, which I will, but I want to show you the other version of that. So what if I did 1 over all of this? I would need it in parentheses or use the alpha y equals for a fraction. And then let's go back to that table again. So see how at 0 you're at 0.5. You need to be over here to see this. We're looking at when do we get less than 0.001. So not until here. This is 0.00026, etc. All right, so then find that sum. So you can either type it in, type it out, or remember, we do have summation in our calculator. I want to clear onto my home screen. So let's see, what was this series? We just said we're going from 0 to 4. So S4 is the sum from 0 to 4 of this thing. Do not ignore the alternating piece. All right, so let me type this in. So math, summation, x equals, x equals 0 to 4 of -1 to the x over 2 to the x times x factorial. Okay, have I typed that in correctly? I'm double checking. This is what that answer is. Let's see what that is as a decimal. And let's compare that to what the sum is supposed to be, 1 over the square root of e. Pretty close, right? We were supposed to be less than 0.001, so that means they want the first 2 decimal places ought to match. And we did a little better than that. The first 3 decimal places match in this one. All right, so that is 0.606778083 repeating. All right, guys, that finishes this review. So if you're looking to practice things, I would just go back through some of the old homeworks, redo questions that you might have had problems on. Make sure you've done the multiple choice review maybe a couple of times. We should be pretty prepared for this test.